History Feather. This is an oscilloscope, and its job is to measure a time-varying voltage signal. It's used in electronics. This is the time axis here, and this is the voltage axis. So this is voltage versus time. And I'm feeding it my phone, electrical signal from my phone. So I'm sending electrical signal to here, and I'm also sending it to the speakers. And you're hearing from the speakers. So that's what this device is. And we're not going to use that for it. We're going to use this device, this oscilloscope, for something different today. Today, what we're going to use the oscilloscope for is, I'm just going to, let me adjust some things here. Line. All right, so what this device is, that looks like a line right now, and what it is it's actually a dot that's just moving quickly. I can slow it down, and there you can see that it's a dot. So it's slowly moving across the screen, and I could play some music again. And let me go back to here. Oh, I gotta take this off here. All right, so now I'm playing the music through there. And you can see the voltage is going like that, but you don't see the signal because it's moving so slowly. I would have to, you don't get a sense of what the shape of the signal is unless I expand in on time there. Uh-oh. Lost my music. There we go. All right. So, but we're not going to use that for that today. We'll look at that more when we study sound. So here we go. It looks like a line, especially if I go fast enough. It doesn't blink at all. It looks like a line, but again, it's just a traveling dot. Here's our oscilloscope, and back here, you can see it's pretty deep. And the reason it's deep is because what you're seeing on the screen is there's an electron gun here. It boils off electrons off an electrode, and the electrons that get accelerated through an electric field, it gets launched out this way, and as it's going, it uses plates to steer the field, right? You got to make you got some plates that are like on this side and that side that are causing it to scan right to left, and then you have plates above and below causing it to go up and down by varying the electric field. So we're actually firing electrons through here, and they're hitting the screen. So we should be able to bend those electrons with a magnetic field, and that's your job, is to figure out how to arrange the magnetic field to get the electrons to bend in the way you want them to. So today, what we're going to try and do is take that electron beam and send it through a magnetic field. Let's go like this. I'm going to take this bar magnet as north and south, and by understanding the field between the magnets, I want you to figure out how should I put this on the screen to get that beam that's going straight across to bend down. Right? I want the screen to... I want that line to bend down. Instead of going through this center line, I want it to bend down. And how should I arrange my magnet to do that, to accomplish that? Should it be like this? 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 How should that be? All right? So take what we've learned about charged particles moving in magnetic fields and figure out how should we arrange the horseshoe magnet. Should the north be above the line? Should the north be below the line? Should the north be on the line to the left? Or should the north be on the line to the right? Remember, we're trying to bend the beam so that it is below that center line. It normally goes on the center line, and we want it to bend below. So do an analysis. You got to figure out what the field looks like at the ends of the horseshoe magnet. And once you know that, you need to do a thought experiment about a charged particle moving through the magnetic field to figure out how should I arrange that horseshoe magnet to get the beam to bend below the line. All right, good luck.
Mystery Physics.